Hello and welcome. So, first off, we have used the following matrices to answer the question below. Alright, so we have G and Z are our two matrices, and we're asked to find that after we multiply the G plus Z and G minus Z together, what's the resulting matrix? First thing you gotta figure out is this even possible? Well, first off, when you are adding subtracting matrices, they gotta be the exact same dimensions. So we have 2 rows, 2 columns, 2 rows, 2 columns, right? They are the same. Perfect, right? That means we can do the sum and difference, the addition subtraction, no issues. Then we gotta worry about the products, right? If we have a resulting 2 by 2 matrix from our G plus Z, and we have another 2 by 2 matrix from G minus Z, well, if we multiply them together, is there an issue? No, right? The 2's match and your resulting answer is also a 2 by 2. You're good to get started on this. There is a few ways we can go about this. Is we could just attempt to, goodness gracious, lost my words for a minute. Algebraically go about this, where we could actually distribute the G's and the Z's together, right? And then see where we go from there. So then we have G squared, right? G times G is G squared. And then we have essentially negative Z times G. And then the other direction, where we have, because we're multiplying it to the right, notice I multiplied G to the right, which means the Z we multiply here will also go to the right. So plus G times Z, and then minus Z squared, because Z times Z is Z squared, right? When you're looking at this, you have to be very careful. Matrices are one of those operations in mathematics where it's not what we call commutative, meaning that A times B is not necessarily the same thing as B times A. And most often in matrices, they're actually not the same, which you'll notice that you'll multiply one direction and it works, and maybe the other direction, the matrix doesn't even exist. And so that's what we have to be careful of. If when you multiply them both directions you get the same thing, then these could essentially cancel out, and G squared minus Z squared is the equivalent of it, right? But it may not be, in which case I would highly recommend just do this by what you see, right? Do the sum, do the difference, then multiply them together. Okay, so I've already written it out below to save us a little bit of time. Let's go right into it. Adding matrices, you got to make sure your first entry goes to your first entry. So -6 plus -1, -7. Right? 0 minus 2, -2. 2 plus 0, 2. 3 minus 1, 2. Okay? And then from there, that's your first matrix, and that's being multiplied to the matrix of our other one. So from here, personally, what I would do is I would actually just distribute that negative, make our lives a little bit easier, so that changes the signs of everything in there. Now, technically, negative times 0, it's still 0. It's not going to change anything. So we have -6 plus 1. That's going to be -5. 0 plus 2, 2. 2 plus 0, 2. 3 plus 1, 4. And now you're set to do matrix multiplication. Now, for matrix multiplication, that goes row by column, where the entries correspond with each other. So -7 multiplies to -5. That's 35. Second entry to second entry, to -2 times 2, -4. And that is the first entry of our resulting 2 by 2 matrix. And then we just essentially rinse and repeat, where we go first row, second column. So -7 times 2, -14. And then we have -2 times 4, -8. Okay, and then keep going through that exact same process again. So second row, first column. So that'll be -10 plus 4. Go to the next column. That'll be 4 plus 8. And then simplify that down one more time. 35 minus 4, 31. -10 plus 4, -6. -14 minus 8, -22. 4 plus 8, 12. Almost said 16 there. And that's it. That's as simplified as it gets. All of your numbers are together, and that's your final answer. Put that right into your answer box. Use your matrix tab to get a 2 by 2 matrix, and you're good to go. You're done. Right? Finished. And that is it. Thanks so much for watching.